Continuing lesson 17.1, analyzing polls. When analyzing results from polls, consider the following. First, the sample should be a simple random sample, not an inappropriate sample, such as a voluntary response sample. Second, the confidence level should be provided. It is often 95%, but media reports usually fail to identify the confidence level. Third, the sample size should be provided. It is often provided by the media, but not always. Fourth, except for relatively rare cases, the quality of the poll results depends on the sample method and the size of the sample. And the size of the sample. But the size of the population is usually not a factor. Caution. Never think that poll results are unreliable if the sample size is a small percentage of the population size. The population size is usually not a factor in determining the reliability of a poll. Sometimes we want to better understand a confidence interval that might have been obtained from a journal article or technology. If we already know the confidence interval limits, the sample proportion, or the best point estimate, p hat, and the margin of error e can be found as follows. Point estimate of p is p hat equals the upper confidence interval limit plus the lower confidence interval limit divided by 2, or the mean of those numbers. The margin of error is E equals the upper confidence interval limit minus the lower confidence interval limit divided by 2. The article High-Dose Nicotine Patch Therapy by Dale Hurt et al. Includes this statement. Of the 71 subjects, 70% were abstinent from smoking at 8 weeks, 95% confidence interval, 58% to 81%. Use that statement to find the point estimate, p hat, and the margin of error, e. We get the 95% confidence interval of 0.58 is less than p is less than 0.81 from the given statement of 58% to 81%. The point estimate, p hat, is the value midway between the upper and lower confidence intervals, the mean. So we get p hat equals upper confidence limit plus lower confidence limit divided by 2, which is equal to 0.81 plus 0.58 divided by 2, which is 0.695. The margin of error can be found as follows. E equals upper confidence limit minus lower confidence limit over 2, which is equal to 0.81 minus 0.58 divided by 2, which is 0.115. A confidence interval can be used to informally address some claim made about a population proportion. For example, if sample results consist of 70 heads in 100 tosses, the resulting 95% confidence interval of 0.610 is less than p is less than 0.790 can be used to informally support a claim that the proportion of heads is different from 50% because 0.50 is not contained within the confidence interval. If we plan to collect sample data in order to estimate some population proportion, how do we know how many sample units we must collect? If we solve the formula for the margin of error E for the sample size n, we get the following formula. N equals z sub alpha over 2 squared times p hat times q hat over e squared. The formula requires p hat as an estimate of the population proportion p, but if no such estimate is known, as is often the case, we replace p hat by 0.5 and replaces q hat by 0.5 with the result given in this formula. N equals z sub alpha over 2 squared times 0.25 all over e squared. Replacing p hat and q hat with 0.5 results in the largest possible sample size, so we are sure that the sample size is adequate for estimating p. Requirements. The sample must be a simple random sample of independent sample units. If a reasonable estimate of p hat can be made by using previous samples, a pilot study, or someone's expert knowledge, use the formula n equals z sub alpha over 2 squared times p hat times q hat over e squared. If nothing is known about the value of p hat, use the formula n equals z sub alpha over 2 squared times 0.25 over e squared. If the computed sample size n is not a whole number, round the value of n up to the next larger whole number. So the sample size is sufficient instead of being slightly insufficient. For example, round 1067.11 to 1068. When the author was conducting research for this section of the book, he could find no information about the percentage of adults who make online purchases. Yet that information is extremely important to online stores as well as brick and mortar stores. If the author were to conduct his own survey, how many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points? For A, assume that a recent poll showed that 80% of adults make online purchases, and B, assume that we have no prior information suggesting a possible value of the population proportion. A, assume that a recent poll showed that 80% of adults make online purchases. With a 95% confidence level, we have alpha equals 0.05, so z sub alpha over 2 equals 1.96. Also, the margin of error is E equals 0.03, which is the decimal equivalent of 3 percentage points. The prior survey suggests that p hat equals 0.80, so q hat equals 0.20. We have an estimated value of p hat, so we use the first formula. P hat equals z sub alpha over 2 squared times p hat times q hat over e squared, which is 1.96 squared times 0.80 times 0.20, all over 0.03 squared. That gives us 682.951, which we round up to 683. We must obtain a simple random sample that includes at least 683 adults. Assume that we have no prior information suggesting a possible value of the population proportion. With no prior knowledge of p hat or q hat, we use the second formula. P hat equals z sub alpha over 2 quantity squared times 0.25 all over e squared, which is equal to 1.96 squared times 0.25, that's not supposed to be squared, over 0.03 squared, which gives us 1067.11 or 1068 when we round up. We must obtain a simple random sample that includes at least 1068 adults. Try to avoid these 3 common errors when calculating sample size. Don't make the mistake of using E equals 3 as the margin of error corresponding to 3 percentage points. If the margin of error is 3 percentage points, use E equals 0.03. Be sure to substitute the critical z-score for z sub alpha over 2. For example, when working with 95% confidence, be sure to replace z sub alpha over 2 with 1.96. Don't make the mistake of replacing z sub alpha over 2 with 0.95 or 0.05. Be sure to round up to the next higher integer. Don't round off using the usual round off rules. Round 1067.11 to 1068.